All right, so let's just go over your steps, kind of everything that you're going to have to do starting from now. So the first thing that you're going to have to do is you want to be able to make sure that all of your denominators are completely factored. All right, so completely, oh my gosh, I just forgot how to spell completely. Is it E-L-Y? I don't know why.
I don't know either.
E-L-Y. I don't know.
It's E-L-Y.
It's E-L-Y. I don't know why.
I can't spell it either.
I don't know why I can never spell that word. Completely factor the denominators.
I'm there with you to say.
I can spell definitely. I always misspell separate.
This is math class.
I know, but there's like 2 words I just can't spell to save my life. And completely is one of them. And you would think that because we spell completely all the time with like everything that we do, like I would spell it by now. I can't. All right, so completely factor the denominators. So that means that even if you're just factoring out like one constant, right? Right? Or if you're doing like a difference of squares or whatever, you need to make sure that they're all factored so you can see all the factors. All right? Bless you. All right. The second thing you have to do is you want to determine your LCD. All right. So you want to look to see like what factors you're going to need. Now that you're going to have a lot more factors, you need to make sure that you look to see what all of them are going to need to include. All right. And then the rest is pretty much like what we've been doing. So you're going to multiply each fraction by the missing factors. The missing factors. All right. So that way we can make sure we're trying to get a common denominator for everything. All right. So when you're multiplying, make sure that when you multiply that you remember to do the top and the bottom, so that way you can distribute and do everything you need to do to combine like terms in the top. Now the parts that we haven't, I think you had some on your homework, didn't you have questions where you had to factor after you did this and see if you can cancel common factors? Did that come up on your last homework assignment on the pink sheet?
It did, but I didn't.
You did. It did, but you didn't do it. Uh-oh. All right.
I think you said we stopped before you said we could stop.
All right. So you want to factor the numerator if possible. And simplify. All right. So if you can factor something in the top and you can cancel it with something in the bottom, that's fine. Right. And then the only other thing that you have to add on there is make sure you add your restriction. Your restriction or conditions. So those are like our steps. We gotta make sure we do all of those now. I know it's a lot. It looks like a lot, but it's less than you think. I mean, because we've already been doing the first 4. Oh no, sorry, the first 4 and the 6th one. So the only thing you have to add in now is like 5 and a little bit extra on 1. So let's just look at a couple. Like I said, we only have 2, but we're just going to make sure that we get hit everything, so that way you're completely simplified. You have to do number 5 so you can make sure you're completely simplified. So let's see. Like I said, we're only going to do 2 examples because I'm not trying to get super complicated, but we need these 2 examples so that way when we solve our rational equations next week, that this is what we have to do for like most of it. Right? And then we got to add on. All right, so we're going to have x over x minus 2. Right. So there's one fraction. And I want to add to that the fraction 4 over x squared minus 8x plus 12. And then I want to subtract 1 over x minus 6. So this is more like what things look like on your work today. And then next week when we solve equations, like we're going to change one of those adding and subtraction signs to an equal sign and have to solve. So it's going to look very similar to this, just a few different steps. So this first fraction, That's your binomial factor, so just put parentheses around it. Same thing with the third one, binomial factor. And the only thing I have to do extra is I need to factor this denominator. So however you want to do it, this one has an a equal to 1, so you don't have to do an area box. All right, we can look at it and figure out what our factors are. So 2 factors of 12 that add up to be negative 8. 6 and 2. So the nice thing about this fraction is that the 2 factors that are in this denominator are also factors in the others. So we don't have to have too much extra. This is going to be our biggest denominator, is that middle one. All right. So that's kind of nice. So I'm going to write that down. All right. Now all I need to do is multiply the first and the third fraction by the missing factors. So this one is missing my x minus 6. And then the right-hand fraction is missing my x minus 2. So now when I distribute, I'm going to distribute and put all of my terms in the numerator so I can see them all, and then I can combine after the fact. So then I'm going to distribute the x to both, and I'm going to get an x squared minus a 6x. The numerator from the middle fraction is just a positive 4, so I don't need to do anything to that fraction, just write down what I have. And then remember that this negative is attached to the 1 when you distribute that across. Hopefully I don't mess it up today. So that's going to be a negative x plus 2. Yes. So that's what it looks like so far. We've got our common denominator, and then we've got what all the terms look like at the top that we have to add or subtract. And so now you need to simplify that. All right? So now we're really down to step 4 already, because we completely factored, we figured out our common denominator, we multiplied the missing fraction or factors. When you write this, write it in descending order, so that way if we're able to simplify it down further, it's easier. So we've got x squared minus 7x plus 6. And you need to be down to step 5 now, where we have to look to see if that numerator can be factored some more. And so I'm kind of running out of space, so I'm going to start a new little line down here. Factors of 6 that add up to be negative 7. Yeah. Negative 6, negative 1. All right, so we have a common factor, and we're able to cancel. So I'm canceling my x minus 6. Remember on one of your previous sets of notes, that's going to create one of our restrictions automatically. So when I rewrite this, I have an x minus 1 up top and an x minus 2. I now need to add 2 different restrictions. One is from the factor I canceled. All right, so that can't be 6. I'm not allowed to use 6 because I canceled that particular, that visible restriction. But then the one that's left, I also am not allowed to have 2. All right, so remember, if it's something that's a factor you cancel, you have to add in that restriction from before. And now you also have to add in the restriction of what you can't use with what's left. So you have 2 separate types of restrictions now. And that will be what your final answer looks like. Yes, ma'am. Which what?
How you got the 2 restriction.
So the ones we've been doing like the last 2 days, all right? When you have variables in the denominator, you've been having to say what you can't use in that denominator still. So you have 2 different types of restrictions. When you were just simplifying before, you had to write what the restriction was, like that fraction was equal to another fraction on the condition that the one you canceled out was not usable. So I have to include that, but then the ones we've been doing the last 2 days are anything that you still see that would make the denominator 0, I also have to include as something that's not optional. So you need both, the old restriction and the new restriction together. Yeah?
How did you get the x minus 1 and the x minus 6 on the
We factored this one right here. So when the one we had left up at the top, so we're on step 5, you have to check to see if the numerator is factorable. So that way, if I can cancel one of the ones from the denominator, you want to factor that first. Because if you leave it as the x squared, then you're not completely simplified. It's like writing 6 over 10 as a fraction. Like there's factors you can cancel. So yeah, so you've got this old restriction. All right, so this is the stuff we did before where you have to add in an old restriction. All right, and then you have to look at your new restriction. All right. So you have to have both now, all right, not just one. Huh? Oh, Dean's just talking. All right, cool. All right. Those are all your steps. All right. So it is a little bit more work because obviously this fraction had 3 fractions we were putting together, so it was going to be a little bit more. We'll do one more. I feel like I want to do something different. Okay, so let's do this. Let's do like, so x minus 3 over 2x plus 1. And then I'm going to add 4x over 3x plus 5. And then I think I'm going to subtract off 1 over 6x squared plus 13x plus 5. Now, it doesn't happen 100% of the time, but I want to say like 90% of the time, when you see 2 separate factors in the denominator like this, and then you see a really big one, most likely this one, when you factor, has at least one, if not both, as the factors. All right, so we try to not make it too complicated where you have 4 separate completely factors floating around. So I'm thinking that's going to happen here. So I have to factor this. And I'm probably going to do an area box because that's what I like to do when a is not 1. So 6x squared and 5. So remember, on the diagonal, you're looking for the product of 30x squared. That adds up to be 13x. Oh, that's just 10 and 3. All right, so I'm going to put a 3x here and my 10x down below. Uh-oh, somebody's got the hiccups. If you need to go get water, that's fine. All right. So look, when we factor that bigger trinomial, all right, the factors that are on the outside actually are the other 2. And so this denominator is my bigger denominator that already has those other 2 factors. And so like I said, it doesn't happen all the time, but it happens often enough that you can, get a general sense of what's happening with the fractions at least. All right. So I used all my space off to the right, so I'm going to have to use my space below. All right, so first fraction. All right. Remember that the numerator there is a binomial. So when I multiply this, you have to remember that it's a binomial times another binomial. So I'm going to have to multiply these 2 together. Now, however we got to do that, if you like using area boxes, if you remember how to do FOIL, you have options of how to multiply that. And so this first one is a 2 by 2. And I know my bad habit is to always mess those up. So I'm going to use an area box to multiply it. So just like I did the area box to factor, if I have a 2 by 2, I'm going to use an area box to multiply. You don't have to. I mean, if you have other ways of being able to multiply a 2 by 2, you can definitely do whatever you need to expand out that first fraction in the numerator. All right, so 3x squared minus 9x. So from that first x minus 3 times 3x plus 5, like that product right there, I'm going to get a 3x squared minus 4x minus 15. And that's from that first part. That's from me multiplying this together. That's giving me that. Right, so that's where all of that came from. Now the second fraction, I don't necessarily have to do an area box for that because it's just 4x times that binomial. So I can just distribute the 4x to both terms. And I'm going to get a positive 8x squared plus 4x. And then I just have to remember my minus 1 from that last fraction. So it's a lot more going on over here. So now we can combine all of our like terms. All right, so you've got 3x and 8x, or sorry, squared. So you have 11x squared. It looks like your x terms all cancel out because I have a negative 4x on here and a positive, so those are going to cancel. And then a minus 16. And there is no way for me to factor that numerator. All right, I see an x squared and a minus 16, and if I didn't have that 11 out front, I could totally do like a difference of squares, but I can't do anything with that. So that fraction has to be left alone. What are your conditions going to be? When is this going to be 0?
It's a negative 1 and a negative 5.
Ah, it's the whole fraction. Because you have to set this whole thing right here equal to 0. So it's going to give me a negative 1/2 from the first fraction and negative 5/3 from the other. All right. So remember to take whatever the entire binomial is and set it equal to 0. So if you've got a coefficient in front of that x, you're going to have to remember to subtract and then divide. All right. So this, as gnarly as it looks, is your answer.